Look for the Rainbow is a book based on the story of Noah's Ark and is about a man who survived a flood along with 2 of each animal in the world. Noah built the ark himself because God told him to. This is a well-known story worldwide.
One of the constraints within this model was to ensure the model didn't exceed 40 by 40 centimetres. Our Noah's Ark model has a height of 40 centimetres and both a width and depth of 35 centimetres, thus fitting within the size constraint. Our model is made from a number of different materials, all being recycled, reused or found at home. These recycled materials include cardboard, paper, pop sticks, alfoil, felt scraps and string. Materials found at home include paper clips, cooking skewers, paint, hot glue, pins and googly eyes. The materials used to produce the systems such as tubing, syringes, light bulbs, batteries and wires were all provided during our workshop. There were a number of steps in the process of constructing this model. Our first step was to choose a children's book that we wanted to bring to life and brainstorm what we wanted it to look like. First, we wanted to make the ark the main focus, ideally have Noah up the top, moving side to side and a drawbridge that lifted up and down. We also wanted to somehow incorporate a rainbow because it is a critical part of the story. We first began by choosing the perfect box to be our base, cutting it to size and painting the backdrop. While the paint was drying, we began to construct the main section of the ark and the little house up the top, using scissors, a Stanley knife and hot glue. We decided to cut windows in the ark and make window sills using red paper to enhance the aesthetic and make it look neater. While Abby and I were hot gluing the ark, Olivia was focused on designing and producing a large rainbow for the backdrop. Our next step was to hot glue the roof on top of the ark and hot glue the little house on the top. Prior to hot gluing on the top of the ark, we cut a small hole in the centre to thread the globe through when we were ready to incorporate the systems. We also cut a small hole in one of the corners of the top and the bottom of the back to feed the tubing and wires through to the outside of the model where we could easily access them. We also decided to not completely glue the roof on the small building on the top, so when children were exploring the model, they can lift up the back half and look and see the globe light up inside. Our next step was to make the animals for the ark. During our Week 9 workshop, we were introduced to basic sewing and were challenged to produce finger puppets. We were inspired by this and decided to make all our animals out of felt and make them finger puppets so children could take them off the model and play with them. We were now ready to add and integrate systems into our model. We decided to use pneumatics as our base. The air pressure would push Noah across the ark and in the process would act as a switch to ignite the globe in the small house on top of the ark by connecting the electrical circuit. These two systems are integrated. However, in addition, we also created a drawbridge that lifted up and down using a basic pulley system.
Noah's Ark model design is aimed at Year 1 6-year-olds. However, it fits into the Foundation to 2 year level band and would engage learning for any students from these years. Within the Australian curriculum, under the content descriptor Design and Technologies Knowledge and Understanding, students gain knowledge of learning outcomes where students explore how technologies use forces to create movement in products. The two focused learning intentions from this area are exploring how principles of push and pull are used in design of toys and identifying and playing and experimenting with components such as wheels and available local materials, tools and equipment to solve problems requiring movement. For instance, children may explore push and pull with pneumatic systems which moves Noah back and forth while pulling and pushing the syringe, also completing the electrical circuit, which turns on and off the light. Within the process and production skills, children can explore the learning outcomes where children explore needs, opportunities for designing and the technologies needed to realize design solutions. For example, materials such as wheels and string were used for making design solutions of opening and closing the drawbridge. To extend on children's knowledge of learning outcomes, children may be advised to use similar materials and create their own design solutions. A pneumatic system is incorporated into our model and moves Noah across the top of the boat. Attached to the back of the boat with a hot glue gun is a syringe which is attached to a plastic airline tubing which stores compressed air. The air is trapped in the tubing as another syringe is placed at the other end, storing the compressed energy. When the tube behind the boat is pushed, it moves the other syringe out, which moves Noah to the right. When the syringe is pulled, it moves Noah to the left. The pneumatic system is integrated with the electrical circuit. Circuits allows for small amounts of energy to be passed around in a continuous loop of conductor material. When the syringe is pushed in and Noah moves to the right, the wire attached to the metal clip, which is the conductor, completes the circuit and touches the other clip covered in alfoil to allow for more surface area. The battery is the supplier of electrical energy, connecting to the conductor, allowing the current to flow to the light bulb, which is the user of electrical energy, to another conductor which connects to the battery. The drawbridge opens and closes with a pulley system. As you can see here, the handle is spun around the string attached to the door, winds up the wheels are attached to a skewer and pulls the door to a close. When you spin the handle the other way, the door opens, allowing the animals to board the boat.
Throughout the process of constructing this project, Noah's Ark, we had different hurdles that we ran into along the way. Beginning this project was probably the easiest part of it all because we were just making the base of it, colouring and decorating the set. We didn't have to make anything move and work just yet. So throughout this, we didn't have any major issues to overcome. We did run into some issues that we had to solve. We struggled to keep the syringes in place, and due to this, it affected the way it moved when we would have to put Noah on it so that Noah was able to go from side to side. This then led to the electrical circuit light bulb not working very well because there was not enough pressure pressing on the paper clip to make the light bulb come on and not be dull. We solved this issue by using sticky tape and hot glue to make the syringe stay in place for Noah to then be able to move, but the syringe still did not have enough pressure on the paper clip to be as bright as it should be. One of us had the idea to put our foil on the paper clip to make it bulkier, and then this would allow the syringe to apply enough pressure to make the electrical circuit light up brightly. This plan actually worked and it was a good solution. We noticed that the drawbridge was not opening all the way, so we decided to glue pop sticks on the top of it to make it heavier so it would roll down easier. This then created an issue of the door not winding up properly as we had made it too heavy, contradicting the issue. So we solved a problem, and in the process we created another issue that we needed to figure out. We solved this complication by hot gluing the wheels to the skewer to make it secure and stop the wheels from spinning against the skewer. Our project has 3 systems that are stable and work effectively when in use. Our model is appealing to children and it draws them in and makes them want to play and see how it operates. Our model is also easy for children to use and play with. They may require help when moving the syringe, but it is effective for children to use and experiment with.